In this problem, we're given that the golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. And we're asked to find the probability that a golfer scored between 66 and 70. Now, if you'll notice, this is the same information we were given in a previous problem. The difference is that we're finding the probability on an interval instead of the probability of an at most or at least for a specific value. So in this case, we're finding the probability between 66 and 70. We're given the mean is 68. The standard deviation is 3. And again, the key here is how we solve this is that it's normally distributed. That's an indication we're going to use z-scores. So remember the formula is z equals the value in question minus the mean divided by the standard deviation. So first we'll find the corresponding probability for 66 or less, and then 70 or less. So for 66, our z-score equals 66, the value, minus the mean, 68, divided by the standard deviation of 3. That equals negative 2 divided by 3, or approximately negative 0.67. And we're using a decimal approximation here because our z-score charts are given as decimals. So we go to our z-score chart, we find the z-score of negative 0.67, and the probability corresponding to that is approximately 0.2514. So now we repeat the process for the other end of our interval, the value of 70. Z equals 70 minus 68, the value minus the mean, divided by the standard deviation of 3, which equals 2/3, positive 2/3, which equals approximately a positive 0.67. Again, we go to our z-score chart. We look up a z-score of 0.67, and the probability that corresponds to that is approximately 0.7486. Now to find the probability of the interval, the probability that 66 is less than x, which is less than 70, we subtract these two probabilities. So it's the probability of 70 minus the probability of 66, or the probability corresponding to them because it's the probability to the left of those values. So 0.7486 minus 0.2514, and that equals 0.4972. So what that means is that the probability that a golfer scored between 66 and 70 is approximately 49.7%. Now don't forget, it's important that you remember how to do this by hand, but when we're allowed to use our calculators, we can always use the normal CDF function on our calculators to find the same probability. And remember that's second and then the DISTR, which is above the VAR button. So normal CDF, we put in our lower bound first of 66, then our upper bound of 70, then the mean, which is 68, and then the standard deviation, which is 3. And when we hit enter, we get approximately 0.495, which would then correspond to the probability that a golfer scored between 66 and 70 being approximately 49.5%. Now, if you'll notice, there's a slight difference in these two percentages we found. The most likely reason for that is that we had to find a decimal approximation or use a decimal approximation of z, whereas the calculator is going to use an exact value or a more exact value for z. So technically the normal CDF function is probably a little bit more accurate than finding the z-scores and using a z-score chart.